Howdy, howdy. Welcome to part 2 of classifying matter. Once again, this fits with Science 8, mix and flow of matter, and Science 9, matter and chemical changes. Let's get started. All right, so we're going to first of all start with breaking pure substances into two groups. Remember, pure substances means that it's the same throughout the entire thing, but we can break this down. Our first one here is an element. An element is basically when it's exactly the same thing all the time. So notice here that these are the exact same little elements here. So this would represent something like oxygen, O2, because oxygen comes in pairs. Elements can also be, for example, if this is my little beaker, it can be just single ones in here like this, and that's also perfectly fine. You know, it's an element because they're found on the periodic table of elements. So if you notice on the periodic table, it is just one box, like one thing, like just hydrogen or just scandium, then you know you have an element. That is the key thing for elements. So once again, elements are one thing, they cannot be broken down. Our other side here is compounds. So compounds are when you have two or more elements that are hanging out together. So for example, with this little compound here, notice I have one oxygen with two little hydrogens, sort of what that represents here. So that would be a compound. Another type of compound would be table salt or salt, which is NaCl. So when I go over here, my sodium is found over here, and my chlorine is found over here. So because I'm using two different boxes on the periodic table, that tells me it's a compound. I can also recognize a compound because there's two capital letters. When I look in the element, for example, like copper, Cu, it's only one capital letter, therefore an element. If I see nitrogen, N2, it's still only one capital letter, element. So two capital letters, or you get a picture, you can see sort of like two elements stuck together. That's a compound. One thing in there is an element. Let's practice this. So I put some pictures up. I want you to think in your head, is it an element or a compound? First one here is, where's my little marker? Oh, there it is I'm hoping that it's an element, because notice that all of these here are the same. So I'm going to label it an element. This one here, I'm hoping you see again, they're all one type, so therefore it's an element. Over here, yo, same thing again. Mix them up, Miss Carter. I know, it's still an element. And over here, what? Still an element. I'm starting to wonder, did I put any compound examples at all in here? Aw, snap. I'm hoping you see that finally here comes my compound examples. Great job at mixing them up, I know. And over here, yep, we still have a wonderful compound in there. Notice how they're all beautifully lined up like this? I'm going to say it's probably a solid chunk of ice or something, where these are sort of more rotating around. So, because what do you call it when they're solid, they kind of arrange themselves. And over here again, notice these are the exact same things pairing up. So this would be an element, right? Oh, our this is a compound. And our last one here is still an element. So clearly I am terrible at finding compound examples, but that is okay. We're now going to go into mixtures. So our mixtures are things that are not the same throughout. You're adding two different things together. So they can be broken into four fabulous groups. Our first one here is a solution. So notice here that we're adding these wonderful blue crystals, which is a solute, into our water. So we're adding two different things together to get a solution. The key thing about a solution is that it looks like it's pure, but yo, it is not. Because it looks like it's pure and it looks like it's all the same thing, we call it homogeneous. So the beginning part, the homo part, means same. So whenever you see that beginning part in science, it means same. So homogeneous means same throughout. That is our pure substance. Notice your apple juice, as long as there isn't little bits in there, it looks like it's the same or it is a solution. Finally, iced tea is a classic example of this as well. Air is our gaseous example of a solution, and also things like brass or steel. They are solid metals that are like melted together. They are not a compound. They're just melted together, just mixed together, so they would be a solution. Mechanical mixtures are super fun. This is when you can see the different parts, and typically you can pull them apart with your fingers and or tweezers. So this is typically involving solids, or it could be like a jello with like something in it. So these are heterogeneous. Heterogeneous means different. So hetero means different. This means that you can see the different parts. So I look over here at my granola, I can pull the raisins out, I can pull the granola out, I can pull this out here, because I can pull the different things apart with my fingers or using tweezers. This over here, this mixed thing of wonderful frozen vegetables, I can individually separate those pieces. Same as this lentil mixture or this fruit salad. So once again, mechanical mixture, you typically can pull it apart with your fingers and or tweezers. Suspensions are super fun. You can see the different parts and you're also able to separate it. The difference between mechanical mixtures and suspensions is that you can't use your fingers to really separate it nice and cleanly. So looking at my example here with sand and water, I would use something like filtration or evaporation. Remember, evaporation is when you leave it out and the water naturally evaporates, or you put it on some kind of like hot plate or stove, don't do that with a beaker, and you would slowly like evaporate or heat the water up. Remember what filtration is? Filtration is where you put some kind of paper in here, could be coffee filter or filtration paper. You pour the liquid in, and anything solid stays here. This is called heterogeneous again, because hetero means different, because look over here, I can see the different parts. So here's an example here, this wonderful salad dressing. You can definitely see how it settles out. Suspensions tend to settle out. And you know, suspensions, you gotta kind of shake it to kind of get everything to mix throughout again. Over here we have oil and water. So you can see here that you can take a paper towel to skim off the oil or evaporate the water off. Here is the classic tomato juice. So tomato juice, you can see all the kind of pulpy pieces in there. So you can use like a sieve to separate them, or orange juice with pulp is the same thing as well with this. Colloids are a little bit different. They're weird. You can see the different parts, but you typically got to shine a light through them or look at them at a window. So sometimes some people will classify them as homogeneous because they kind of look like they're the same, but if you actually hold up to a light, you can see the different parts. So I classify it as heterogeneous. Now, at any point, you can ask me, hey, Mrs. Carter, can I see the different parts? And I will respond yes or no. I'm not trying to trick you on terms of, can you classify everything in this world? No, I just want to know, do you understand that if you see the different parts, it is heterogeneous? Colloids, I classify them as heterogeneous because look at here. Yeah, right here in the solution, you can't see anything through there, but once you shine a light through it, you can see all little parts kind of floating around here. Now, the difference in a colloid and a suspension is you cannot separate it. So classic one is milk. Now, people think milk looks the same, but if you actually look at homogeneous milk, right, or like in Canada we call it that, or like say full fat milk, if you hold it up to a window, you can actually see the little fat globules like floating throughout it. Another example here is like paints and mousses and gels and pudding and all of those. Yeah, from far away, they look like they are like the same thing as solution. But when you actually look at them with a light or into the window or spread them nice and thin, you can see they're not consistent all the way through like a solution. Jello is also another example of a colloid. And so these are all kind of examples of colloids. So once again, on a test, if you're not sure if it's a colloid or a suspension or a solution, you can ask me, hey, can I see the different parts? And I'll say yes or no. And then you can say, can I separate those parts? And I will also answer yes or no, because I just want to know, do you understand what a colloid, suspension, and a solution is? So here's a beautiful example of how you can kind of tell the difference if you say have a flashlight and the mixture in front of you is you can use the Tyndall effect, which means that you look at how light goes through. So solutions, because they're mixed so beautifully, the light is not visible. It goes straight through. However, with both colloids and suspensions, you can actually see the different particles in there because they're a lot larger. They don't dissolve quite as nice, and therefore it scatters the light. So my friends, here's a beautiful, wonderful overview. So once again, matter is split into pure substances and mixtures, all the same and different. Pure substances with the elements. Notice here the copper teapot, all the same. A compound like baking soda, look at that. You can see the compounds right in here, but it's all coming together. Over here we have homogeneous, like tea. Notice it looks like it's the same, but you can see that there are different particles spread throughout. But because they're so nicely dispersed, it kind of looks like it's the same because they're like hidden throughout. I know, very exciting. Then we have our heterogeneous, which is like a big clump of things here, so they're definitely going to show up. So they're pretty the different parts of them. All right, my friends, it's recap time. So we can break pure substances into elements and compounds. We can also break mixtures up into 4 fabulous categories. They are solutions, they look pure, so we call them homogeneous. We have mechanical mixtures. You can see the different parts, they're heterogeneous, and you separate them. We typically use our fingers and or tweezers to do this. Suspensions, you can also separate, we call them heterogeneous. We typically separate them through using some kind of filtration, maybe some kind of strainer, or maybe paper towel to pull the oil off the top, or evaporation. And these are also heterogeneous. And then colloids, we cannot separate them. When you shine light on them, you can tell they're heterogeneous, but depending where you look, some people might argue for homogeneous, but if you're in my class, please classify them as heterogeneous. Thank you so much and have a sciencey day.